Hello everyone, I hope you're all doing well. Today's video is all about exploring sieve analysis of coarse aggregate. We'll be taking a deep dive into ASTM C136, examining 3 different sizes, and discussing how you can find the best portion for each of them. So, sit tight, and let's get started. First, let's take a look at apparatus that we are going to use in this test. Oven. Balance. Sample splitter. Sieves and sieve shaker. In this picture, you can see that a minimum amount of coarse aggregate is specified for sieve analysis of each size. In the next few minutes, I'll be explaining how you can find the best proportion for them to meet the ASTM C33 standard. If you've watched my previous video on making concrete, you'll remember that I mentioned that we should conducting sieve analysis for each size of coarse aggregate to find the optimum portion. Today, I'll be sharing a technique to help you do just that. The next step in the process is sampling. The amount of sample you'll need should be more than 4 times the specified amount shown in the previous picture. For example, for 9.5, 12.5, and 19 mm aggregates, you'll need to take more than 4, 8, and 20 kilograms respectively. Once you've collected the sample, you'll need to reduce it to the amount suitable for testing. It's important to note that the sample test should be approximately the quantity desired when it's dry. To reduce the sample size for testing, I followed the ASTM C702 guidelines. First, I placed the original sample in the hopper and distributed it uniformly from edge to ensure that equal amounts would flow through each chute. Next, I introduced the sample at a rate that allowed it to flow freely through the chutes. To further reduce the sample size, I reintroduced a portion of the sample from one of the receptacles into the splitter as many times as necessary, alternating each side, until the desired sample size was obtained. I repeated this procedure for each size of coarse aggregate. Once the samples have been prepared, we need to place them in an oven at a temperature of 110 plus or minus 5 degrees Celsius for 24 hours to meet the standard requirements. After that, we remove the samples from the oven and weigh them to ensure that we have the desired amount for testing. If you found this video helpful, please take a moment to hit the like and subscribe buttons to support my channel. To start with the sieve analysis, it's important to first prepare the required sieves as per the guidelines of ASTM C33. This involves obtaining a set of sieves with different mesh sizes suitable for the range of particle sizes in your coarse aggregate. In this case, we will need sieves with sizes of 25, 19, 12.5, 9.5, 4.75, and 2.36 millimeters. After obtaining the sieves, it's time to weigh each one separately and take note of their individual weights. To perform the sieve analysis, you first need to arrange the sieves in decreasing order with the smallest at the bottom and the largest at the top. Then, place the sample on the top sieve and agitate the sieves for a sufficient period. In our test, I set the timer for 5 minutes. After shaking, I determined the mass of each sieve with the aggregates. Then I subtract the initial weight of each sieve from the value that I obtained and find the weight of aggregate retained on each sieve. We should add all the aggregate weight together and compare the total mass of the material to the original dry sample mass placed on the sieves. If the amounts differ by more than 0.3%, we can't use the results and we should repeat the test. Now, I did the same process for the other 2 aggregate sizes, and I wrote down the results. But to save time, I won't show you the same procedure for those. Alright, let's dive into the calculation part. So, in the next pictures, you can see the values we found during the test. First, we need to find out the weight of the aggregate retained on each sieve. How do we do that? We simply subtract the weight of the sieve from the weight of the sieve and aggregate together, and we get the weight of the aggregate retained on the sieve. Easy, right? The next step is to determine the total weight of the aggregate retained on all sieves. We compare that weight to an acceptable weight, which is calculated by multiplying the initial weight of the aggregate by 0.3%. In our case, that's 2,432.7 grams, and we're in luck because the total mass of our material is 2,433.8 grams, just a bit more, but still good. Now, we can move on to the retained portion of the aggregate on each sieve. How do we find that? It's simple, we just divide the individual weight of the aggregate retained on the sieve by the total weight of our material after the test, which is 2,433.8 grams. Great! So now that we have completed the sieve analysis and calculated the individual weights, total weight, etc. for each aggregate size, we can move on to determining the optimal portion for each size in our mix design according to the ASTM C33. This standard provides grading requirement for coarse aggregate. The standard specifies the maximum and minimum percentages of each aggregate size that should be used to achieve a well-graded aggregate. As you can see in the sieve analysis for all sizes of aggregate, we have listed the upper and lower limits of acceptable grading from ASTM C33. To begin, I assumed that we should take 30% from 9.5 millimeters, 35% from 12.5 millimeters, and 35% from 19 millimeters. I then multiplied the cumulative passing percentage values for each aggregate size by their respective percentage. After adding these values together for each size, I compared them to the requirements of the ASTM C33 standard. As you can see, the values were within the acceptable range for the first 3 sieve sizes, but the value for the 4th sieve size, sieve number 4, should be between 0 and 10. Since the 9.5 mm size had the highest portion in this size, we decreased its percentage to 25% and increased the percentage of 19 mm aggregate to 40%. We then rechecked the values against the ASTM C33 standard and found that they were all within the acceptable range. Therefore, for our mix design, we should use 25% 9.5 mm, 35% 12.5 mm, and 40% 19 mm coarse aggregate. At the end of the test, I drew a sieve analysis curve for our results and included the upper and lower limits from the ASTM C33 standard to visually compare and confirm that our aggregate mix design met the grading requirements. Great! That's the end of today's video. I hope you found it helpful. If you did, please remember to give it a thumbs up and subscribe to the channel. I'll see you in the next video.